paper 5. Right. It's question number 1. Find the set of values of lambda for the function fx given by this to be positive for all real values of x. Right. The function given like this, fx, right? Fx equals 2 lambda x squared plus 2 times lambda plus 4 times 6 plus 9. Okay. Fx equals 2 lambda x squared plus 2 times lambda plus 4 x plus 9 to be positive for all real values of x. Right. This fx should be positive for all real values of x. Yeah, you can see here this is a quadratic graph. Basically, for a quadratic graph, there are two shapes, minimum or maximum. But here this fx means of this graph y value. So then asking is, right, basically the two shapes should be people, this the minimum graph or this the maximum graph. Are the basically the two shapes this fx can take because it is a quadratic graph, right, having x squared term there. Okay, so then here fx means the y value of the graph. Y value of the graph, that is fx. Then of the graph, this y value of the graph should be positive for all real x. In the sense, when you move from this end, right, to positive infinity, on the x-axis, we move from negative infinity up to positive infinity. Okay. So for that interval of x, every x value, at every x value, the y coordinate should be positive. Fx means y coordinate. Right. Now here, if you see like that, if this graph represents a maximum graph, you can see the y coordinate, right, not all become positive. Some of the y coordinates are people negative. So therefore, in order to satisfy the requirement, this fx is the y coordinate of a quadratic graph. That y coordinate of the quadratic graph should always be positive for any value of x. Then definitely our logic is people definitely that representing graph should be a minimum graph like this, and the graph should not cut the x-axis. If it cuts the x-axis, right, so then the graph will be like this, no, right? Graph will be like this. Then you can see between these two values of x, the y value become negative here. Our requirement will not be satisfied. So therefore, in order to occur the condition there, the fx should be positive for all real values of x mean definitely the graph should represent a minimum graph. And secondly, that should completely lie above the x-axis. Okay. So for this to be a minimum graph, you know, first condition required is this x squared coefficient, right? This one should be positive. You know, x squared coefficient positive means the graph is minimum graph, correct? And this means people 2 lambda positive mean lambda should be positive. Second condition, the graph should be like this without cutting the x-axis. That means the discriminant, it should not have real roots. No? If the graph doesn't cut the x-axis, the graph has no real roots. That means Imogen roots. It means delta negative, right? Delta negative. Delta negative, right? Delta means b squared minus 4ac less than 0. B means this figure. A is this. C is this 9. Right? B squared. Square this. Substitute here. Right? This is the first condition. Lambda should be positive. B squared means 2 times lambda plus 4 perfect squared minus 4 b squared minus 4. A is this 2 lambda. C is that 9. This should be negative. Right. We simplify this. 4 lambda plus 4 perfect squared into 18 lambda less than 0. We can divide both sides by 4. That means we can cancel down this 4. Correct, no? Now, we'll simplify this. What do we get there? Lambda squared plus 8 lambda plus 16 minus 18 lambda less than 0. Right? Now here, when you simplify this, lambda squared minus 10 lambda plus 16 less than 0, you can factorize this. Lambda here, minus 8, minus 2. This way we can factorize that. Okay. Then we can take the region for lambda, equate this bracket to 0, lambda 2, mark here, this to 0, lambda 8. Correct, no? Now here we don't have equal sign, then both these values we don't take. Right. Now, 0 lies in this interval. Put 0 for this place of lambda. 0 minus 8 is this is minus 8. 0 minus 2 is this is minus 2. Minus 8 into minus 2 is plus 16. We get plus 16 less than 0 is wrong. So therefore this region does not satisfy. Then this will satisfy. This will not satisfy. So then region of lambda which satisfies this inequality between 2 and 8 like this. Yes, number 2. Now we must take lambda should satisfy this and this both. This says lambda should be positive, but this also available in the positive range of values this lambda in this case in number 2 takes. So therefore common region for 1 and 2 going to be again this, right? By 1 and 2 common region. Common region we get lambda this, no? Right? Then a greater than 2. This is how we take the first answer. Okay. Number 2. Find partial fractions of 1 over x minus 1 into x plus 1. Hence find partial fractions of this. Right. We'll count that. We can find partial fraction of this 1 over x minus 1, x plus 1. 1 over x minus 1, x plus 1. We can write a over x minus 1, b over x plus 1. We can multiply both sides by the left hand side denominator x minus 1 into x plus 1. This will be 1. A times, when I write this here, we get a times x plus 1, b times x minus 1. Now we'll equate the coefficients of x to the power 1 in the left and right. Here we get ax, here we get bx. No? Then coefficient of x in the right hand side, a plus b. Left hand side, we don't have x term, 0. Now we get x power 0. Here a, here minus b. Then this is 1. Number 2. Right? And in 1 and 2, we can find a. 2a equals 1, a equals half. By 1, you can say people, by 1, b equals minus a, no? Then b equals minus half. Then we can write the partial fractions for the given one. Okay, right. So the partial fractions, then you can write substitute for a and b there. Therefore, we can write 1 over x minus 1, x plus 1, equals a. A is half. Then we substitute like this. 1 over 2 times x minus 1 minus 1 over 2 times x plus 1. This is right. Now, secondly, asking the partial fraction of 1 over x minus 1 squared, x minus 1 squared into x plus 1 squared, right? This is asking. Right, you know, this means, right? This one I can write how perfect squared of this, no? This means perfect squared of this. But this one, this I can write this within bracket, no? Then we can write 1 over 2 times x minus 1 minus 1 over 2 times x plus 1. Okay, perfect square, right? Now you can think people this whole thing you can take as a. This you can take as b. AB. Then here we have a minus b perfect squared. A minus b perfect squared. You can simplify now. What do you get there? A squared. Square this whole thing. 1 over 4 times x minus 1 squared. Secondly, multiply this 2 and again that multiplied by 2. You got to get 1 over 2 times. Right now, this and this when you multiply, we get this and this 4 no. But when you multiply that again by 2, another 2 come in here. X minus 1, x plus 1 here. Right? Okay. Then the third one come in like this. The perfect square of this, it is 1 over 4 times x plus 1 perfect square, right? Now you can see here, this part when I take separately, this is really nothing but 1 over x minus 1 x plus 1 is again this. For that I can put this here. Okay. Then I can write this equal 1 over 4 times x minus 1 perfect square. This minus half I can keep before. Then we have 1 over x minus 1 x plus 1 is this. 2 times minus 1 2 times x plus 1. Okay, that I substitute for this. After that we have this plus 1 over 4 times x plus 1 perfect square. Now by this half we have to multiply this and this both. Then you get the partial fraction of the required part. Okay. Then we get 1 over 4 times x minus 1 perfect squared. This and this when you multiply 1 over 4 x minus 1. This and this plus 1 over 4 correct no 1 over 4 x plus 1 and here 104 6 plus 1 perfect. This is how we take the partial fraction of that. Okay. Right. Next one, question number 3. Number 3. It says something like this. Given y equals sin inverse 6 divided by square root of 1 minus x square. Y equals sin inverse 6 divided by square root of 1 minus x square. Okay. Right. We'll take the cross multiplication first here. 1 minus x squared y sin inverse 6 is a u function, is a v function, right? UV product form only, we have to now differentiate these first now, right? Okay, now we can differentiate left hand side. Keep this 1 minus x squared as the same, derivative of y dy by dx. Keep y as the same. When you differentiate this, first you have to differentiate the power, this root sign. When you differentiate this root sign, you know what is the answer? 1 over 2. The same thing first. Right? So far we have differentiated the root sign. That is this. That should be multiplied by derivative of the function inside the root sign. One is a constant, 0 minus x squared derivative is 2x. Right. Go to right hand side. 1 over root 1 minus x squared. Understood? Right. Now people will simplify here. This we can cancel down. First answer asking to prove what. Meantime, people, we can multiply this by 1 minus x squared root. This left and right we multiply by this factor. Then this will be 1 minus x squared dy by dx. Here minus x and y. Here equals 1. Minus xy you can take right hand side, no? 1 minus x squared dy by dx. This will be, now we cancel down, no, this and this. When you multiply this by this, these two will cancel off. Minus xy, take right hand side plus xy product. After multiplying this by the same thing, that two will cancel off and give in 1. 1 minus x squared dy by dx equals xy plus 1. That means 1 plus xy, correct. Secondly, ask another one. Second derivative relation asking. Second relation asking there. So the first answer is we differentiate again with respect to x. Plus xy, no, right? Again we differentiate this. This as your u function, this as your v function, right? Then here 1 minus x squared, keep as the same. When you differentiate this, we get second derivative, d2y over dx, plus keep this v as the same, and derivative of this 1, when you differentiate 0, x squared derivative is 2x, then minus 2x. Right hand side 1 equal to 0. This you have differentiate u into v. X times dy by dx plus y, root of x is 1. 1 minus x squared d2yo dx2. Here people, minus 2x dy by dx. Take this also to the left hand side. We get minus x dy by dx. Here minus 2x. Here minus x minus 3x dy by dx. And that y when you take left hand side minus y. Answer coming, no? Right. Minus 3x dy by dx minus y equals 0. Second answer coming like this. Okay. Question number 4, the next one. Question number 4. Fourth one. But question number 4 gives us let 2a plus b equals pi by 4. Express tan b in terms of tan a. Ensure that the root of the equation x squared plus 2x minus 1 equals 0 is tan pi by 8. Use the value of tan pi by 8. Okay. Right. We are given there 2a plus b equals pi by 4. Or 2a plus b equals pi by 4. No? Right. 2a plus b equals pi by 4. Subject b by this pi by 4 minus 2a. Now take tan on both sides. Tan b equals tan pi by 4 minus 2a. Right. Tan b equals, the right hand side you can expand by using tan a minus b formula. Tan a minus b formula, you know, tan a minus tan b divided by 1 plus tan a tan b. No? Tan pi by 4 minus tan 2a 1 plus tan pi by 4 tan 2a. Tan a minus tan b divided by 1 plus tan a tan b. You know tan pi by 4, 1. Tan 45, no? 1. Here. Here 1 minus tan 2a divided by 1 plus tan 2a. Now, what I do is, people, we substitute for this tan 2a. You know, tan 2a formula is, what is tan 2a formula? Tan 2a formula is 2 tan a divided by 1 minus tan squared a. Tan 2a. Tan 2a formula is 2 tan a divided by 1 minus tan squared a. Put that for the tan 2a. And when you simplify this, you get tan b in terms of tan a terms. Okay. Now we'll substitute for tan 2a there. Then we get tan b 1 minus 2 tan a divided by 1 minus tan squared a. 1 plus 2 tan a divided by 1 minus tan squared a. This way. Then to simplify this furthermore, people, what I do is, the numerator and the denominator, both I multiply by 1 minus tan square day factor. Yes. By this 1 minus tan square day, I multiply this one, this one, this one, and this one. Tan B. When you multiply this 1 by 1 minus tan square day, the same 1 minus tan square day we get there. When this whole term is multiplied by this one, this and that will cancel and give in minus 2 tan A divided by here 1 minus tan square day plus 2 tan A. We get this way. Then tan B equals 1 minus 2 tan A minus tan square day divided by 1 plus 2 tan A minus tan square day. Is the tan B 1 minus tan square day 2 tan A minus 2 tan A divided by 1 minus tan square A plus 2 tan A. Right, we'll take this one as star. Right. Now what we do, people here, we are given 2A plus B equals 5 by 4. So then, what we do is, in this relation, suppose this B angle is 0. Then 2A equals 5 by 4, A equals 5 by 8. Right. Okay. Then you can see here. Now, 2A plus B 5 by 4, let B equals 0. This B we take as 0. Then we get 2A equals 5 by 4, A equals 5 by 8. Right? Okay. People, here we have relation between the two angles A and B. 2A plus B is equal to 5 by 4. For the same relation of the angles, relation between the angles A and B, they are tan relation given by this. Then if we put here B0, since the same B here we have, I can put here 0 for this B. Okay. Now by star. When I put B here, put in B equals 0, we get tan 0 equals the right. 1 minus 2 tan A minus tan square D divided by 1 plus 2 tan A minus tan square D. Okay. Now, you know tan 0, 0. Right? Then this fraction 0. This fraction is equal to 0. For this fraction to be 0, the numerator must be 0. Right? Now, this implies this 1 minus 2 tan A minus tan square D equals 0. Then you can write it as multiply this with minus sign, tan square D plus 2 tan A minus 1 equals 0. This way we get. Now, this is how we match the situation. This is the relation between the angles of A and B. For the same relation between the angles of A and B, the relation between tan A and tan B is given by this. I put here B0, found A pi by 8. Same B here we have, I put B0, then we get tan 0, 0, we got this one. Thereby we got by star this. Then people, this equation, this A means what? This A means the angle. What angle? When B is 0, the angle of A is this angle now. Why? We got this one, people, put in B 0. Understood? So therefore, this angle here, A, should be this pi by 8. Then we can see here, we have a quadratic equation in tan A. Since A is pi by 8, here we have quadratic equation of tan pi by 8. Understood? Now what I do, people, for this tan A here, I write x. But here, A means pi by 8. And then we can rewrite this way. Right? Since A is pi by 8, since A equals pi by 8, we can now write what, people? We may write we may write what? Substituting for this A, pi by 8, tan squared pi by 8 minus plus 2 tan pi by 8 minus 1 equals 0. All right. Now the same equation I can write, put in x. Right. Let x equals tan pi by 8. Therefore, this reduces to, we get what? X squared plus 2x minus 1 equals 0. Then what is x here? Tan pi by 8. And then the tan pi by 8 should be a root of this. Why? X means, here x means what? Answers of x mean what? Of this equation? Answers of x of this equation are called as roots of this equation. But really, what is x? Tan pi by 8. Therefore, tan pi by 8 should be a root of this equation. Okay? Right. And then we can write the answer. Hence, tan pi by 8 is a root of this equation. Hence, tan pi by 8 is a root of this equation. Right. Now, we can consider this as a quadratic equation in x. Then you can write solution for two solutions for x. Understood? Then they should be, one should be answer of tan pi by 8. Yeah. How to write the solution for this? We'll write, people, x equals minus b. That formula you can use. What formula? For ax squared plus bx plus c equals 0 quadratic equation, the solutions of x, the roots of x given by x equals minus b plus or minus square root of b squared minus 4ac divided by 2a. Using that, we can find two answers for x. Understood? Right. B is here 2 minus b plus or minus square root b squared is 2 squared. 4 times a is 1, c minus 1 divided by 2 into 1. We can solve this, people, for two values of x. Let's see what happens. We get x equals minus 2 plus or minus square root. There we get here 4, here 4, 8, root 8. We get root 8 divided by 2. Minus 2 plus or minus this 8 you can write as 4 into 2, no? Its root. Right, now you can write, taking this 4 out as 2 divided by 2. This way we can cancel down. Here we get 1. X has two answers. Right? So, when you take plus sign, we get x minus 1 plus root 2. We take minus sign, terms of x going to be minus 1 minus root 2. But we told people x is what? Tan pi by 8. Pi by 8 angle means 22.5 is the pi by 8 angle. 22.5 degrees pi by 8. That is an angle in the first quadrant. For first quadrant angle, tan value should be positive. So therefore, this is obviously negative, you can see. But this is positive, root 2 greater than 1. So therefore, this is a positive answer. So therefore, this should be the value of tan pi by 8. Then we can write tan pi by 8. Therefore, tan pi by 8 is equal to root 2 minus 1. Root 2 minus 1. Okay? This is how we do that. Right. Now we'll come to the question number 5. Right. They were given 3 particles A, B, C. 3 particles A, B, C. Each of mass simple limb are placed in a straight line on a smooth horizontal table with A and B distance simple A apart. And connected by a light inextensible string of length simple A as shown in the figure. The particle B is given an impulse in the direction of AB. Impulse means impulsive force. Suddenly we apply a force like this. Okay. Suddenly we apply force, not like a push in a car or something like that. Suddenly we apply. That is to say, when we strike to a ball with a bat. So such force acts on the ball during a negligible time interval. So that force acts and meantime that disappears. Such force is defined as impulsive force. Here impulse means that. Right. Okay. Such that its velocity just after impact is u. Soon after giving the impulsive force, the velocity of this B is equal to u. That's what this question says. Okay. Yes. So then when we draw the diagram there, right, first location is right. You see, here, be here, right? Soon after giving the impulsive force, B begins to move with velocity u. People, meantime, this O or this A begins to move with velocity u. That's a obvious fact. No, the reason this string is inextensible string. Once the string is taut means stretched to its natural length, right? A. If its front moves with certain velocity, the rear end, okay, should also be moving the same velocity. To say, in a train, when we consider, when the train moves, the velocity of the engine and the last compartment should have the same velocity, acceleration, everything like that. Okay. So then soon after B begins to move with velocity u, the A must also be moving with velocity u. Right? Then what happens is, people, this way after moving, is B collides with velocity u, B collides with stationary particle C of same mass. So I am drawing now soon after the impact, right? The velocities of B and C. This is just before the impact. This is just after impact. For this collision, people, we can apply conservation of linear momentum and Newton's law of restitution. Okay. So at the moment of the collision, the particle A moving with velocity u. At the moment of the collision also, it moves with velocity u. People, you can see here, right? This plane is smooth. Soon after giving the impulsive force, we are given B begins to move with velocity u. Meantime, same moment A begins to move with velocity u. And this plane is smooth. Then while both are moving, A and B both are moving, people, remember, no tension in the spring. They move with uniform velocity u until the particle B collides with C. At the moment of collision, that A still moves with velocity u. Soon after the collision also, people, no but effect to change the velocity of A because of the collision. So therefore, A moves with the velocity u even after the collision between B and C. Now we are going to find at the collision of B and C, applying conservation of linear momentum and Newton's law of restitution, I am going to find the velocity of B, right? Okay. So then I can do it by applying conservation of linear momentum. CLM we apply this way. Before the impact, only B was moving. People don't take this A into the system in this case because the collision takes place between B and C. So then just before and just after the collision will equate the momentum of B and C only, right? Okay. Then we get mv1 plus mv2 as the total momentum after collision. M can be cancelled down. v1 plus v2 equals u number 1. Now we apply secondly Newton's law of restitution this way. What is that? Minus E times relative velocity before impact. All right. Before impact, C at rest. Only B moving. Then relative to C, velocity of B is u here. After impact, again find the velocity of B relative to C. Stop C. Apply V2 leftward. Same V2 apply onto B leftward. V2. Then this B will have rightward V1, leftward V2. Rightward resultant velocity is therefore V1 minus V2. That should come here. That is the velocity of B relative to C after impact. Okay. Number 2. We will ask him to find what? Ask him to find the velocity of B, no, soon after the impact. So V1 only we need to find at 1 and 2. Plus V2 minus V2 will cancel off. V1, V1, 2, V1. Right hand side take U out. Divide by 2. U by 2. 1 minus E. Right. This way we get down. Okay. Now, what is asking next? Next one asking. Also find the time taken after this collision for A to collide with B. All right. Now, our situation is this, people. For the collision between B and C, no time taken. We assume the collision takes place during negligible time. Or really, it doesn't take a time. It's very small time it takes, but that time we neglect. Okay. So then, present situation is this. Soon after collision, people, if I draw the diagram, the particle A is still moving, right, with velocity u. Soon after the collision, B begins to move with velocity v1. Still, the distance between them going to be simple a. Right? Now, okay, asking, right, the velocity, the time taken by this A to collide with this B. You can see here the v1 velocity given by this, no. Obviously, this v1 velocity is less than u. Understood? Less than u. So therefore, we can consider like this v1 smaller than this u. Right? So therefore, relative to B, velocity of A, velocity of A, relative to B, velocity of A, relative to B. That means when you stop this B, what is the velocity of A? Understood? So that you can write velocity of A relative to B. We have to stop B. Apply V1 this way. Same V1 this way. Then this A will have velocity to the rightward direction, u minus V1. Then B is at rest. Now A moves towards B with velocity is u minus V1. What distance that should move to make the collision with B? Simple A. Then A should move a distance simple A with velocity u minus V1. Then we can first write the velocity, therefore the time. Time is what? Distance divided by velocity. Okay. Right. So then we get that one, substituting for V1, A over u minus V1 is this answer, u by 2, 1 minus c. Okay. Then simplify this, multiply this numerator and divided by 2, 2a divided by, here 2u minus u, it's u, right, plus e. Then take that u out, then we get 1 plus 2. This way we can find that time. Understood? Right. Okay. This way we can take that time. Now, question number 6. Right. A and B are 2 points on a horizontal ground such that AB equals simple A. 2 particles P and Q are projected from the points A and B respectively at the same instant and in the same vertical plane. The vertical plane that contains line AB such that they collide with each other after a time t at a point in space. The initial velocities of P and Q are given in the figure. So that u equals root g a and find t in terms of simple a and simple g. Right? Okay. Number 6. We'll come to that. This way. Right. With the particle P. This angle is pi by 6. This is root 3 GA, the velocity is pi by 3. This is U, particle Q is here. The distance between A and B, simple A. Suppose they meet here. The time taken is T. Right. Suppose this height is h from the ground. Let this distance be d. Right. Now, the time taken by the particles are equal for their collision. The height displacement, vertical displacement being equal for both. In first occasion, we apply for both P and Q. The equation of motion S equals ut plus half at squared vertically upwards. During the same time interval, both particles P and Q have moved the same vertical displacement h, right? And then we can write S equals ut plus half at squared, right? Applying S equals ut plus half at squared upwards like this. What do you get? 4. First one, P. What is the vertical displacement? H. Initial velocity, root 3 GA sine pi by 6. Root 3 GA sine pi by 6 times T minus half G T square. This is number 1. Secondly, for Q, the same height, no? Here, U sine pi by 3 minus R times T minus half GT squared, number 2. Take 1 minus 2. Then you know h minus h will be 0. This minus this will be 0. We get what? 0 equals root 3 GA sine pi by 6 means half minus, and here we have T also, right? T minus U sine pi by 3 sine 60 root 3 by 2 times T. You can cancel down this T and also this 2 and also this root 3, right? Then we get here root GA. This root 3 also we can cancel down with this, okay, minus U this side. We get answer first term. U equals root 3 root GA, right? Secondly, people asking what, find T in terms of A and G. Right. Now you can write. Now we apply S equals ut rightward O P. So it moves from here to here just before the collision. Horizontal displacement A plus D. Q moves only D, right? For P, we apply rightward A plus D. Its horizontal velocity component root 3 GA cos pi by 6. Cos pi by 6 times T. U is this, T is this. For Q, what is the distance Q moved from here to here? No? Horizontally, D. U cos pi by 3 u cos pi by 2 times t. Take this as number 3 as n number 4. Then 3 minus 4 we get. Right. What do you get? You get a. D will cancel no when subtract. Here root 3 GA cos 30 root 3 by 2 times t minus cos 60 half times t. This and this you can cancel down, no? Then here root 3 3 root GA times t minus u root GAT. Now what is this? 3 root GAT minus root GAT. It's like 3x minus 6. It's 2x, no? 2 times people, I cancel this by 2 means that should be multiplied by 2 here, no? Here we have 2. Okay. Reason cancel in this means multiply both sides by 2. Then here 2 we get. We multiply both sides of this by 2. That's what this cancellation means. Right. So then here we get 2 root GAT. This and this you can cancel down. Then answer comes as subject t. This way a over e root. This time. Okay. Right. Next one number 7, the vector question. Vector question. Given there, and the usual notation, the position vectors of 2 points A and B with respect to a point, fixed point origin O, 3i plus 2j and 2i plus 4j respectively. You see. Okay. Oh. Right. Question vector of A given as 3i plus 2j. Then the point A has the coordinates what people? 3, 2, no? X coordinate is the I coefficient, Y coordinate is the J coefficient. B. Here given Y plus 4j. This way. Asking to show first what? So that O, A and B are non-collinear. Right. People, I will take this angle as alpha. This angle as beta. Okay. If the coordinates of B going to be 2, 4. I can write tan alpha. This opposite side. Y coordinate of this point 2. adjacent side when you drop a perpendicular here. This is the y coordinate of the point A, 2. X coordinate 3. Then tan alpha 2 over 3. Tan beta. Here 4 divided by 2. You can see, people, this ratio 2/3. This is 2. This is 0.6. This is 2. They are not equal. 2/3 not equal to 4 by 2. Therefore, you can write tan alpha not equal to tan beta. This gives alpha not equal to beta. Right? For this OAB to be collinear. Collinear means the 3 points should be on the same line. No? For them to be the same line, this line OB should come on to this OA. Then only the OBA will be collinear. For that, beta and alpha must be equal. But in this case, beta and alpha not equal. Then the 3 points are not collinear. Right? So therefore, OAB are not collinear. Are not collinear. Are not collinear. Right. Next part. Next part asking, let C be the point such that BC equals lambda OA. BC equals lambda OA. BC equals lambda OA. BC equals lambda OA mean, people, BC equals lambda OA mean the BC vector and OA vector must be parallel to each other. Must be parallel to each other, right? So then I can draw it like this. You see, right? This should be point C. Right? I'm asking what? Asking find vector OC. Find vector OC. This one. This vector only we need to find. How to write OC? OC we can write OB plus BC. OB plus BC. OC vector. OB vector 2y plus 4j. BC vector lambda OA, but OA vector 3i plus 2j. Right. Now we'll write I vectors together. Here 2, 3 lambda I. 2 plus 3 lambda I. And here 4 plus 2 lambda j. 4 plus 2 lambda j, like this. Right, next one asking. Show that if BOC pi by 2, BOC pi by 2, BOC pi by 2. Right. So that means this angle, no, given as pi by 2. In this diagram, this angle cannot be pi by 2, but it is possible if this point C lies this way with the lambda negative, then that angle is possible to be 90. Then our lambda should therefore be negative value. That's also asking the answer should be negative. As the answer negative, it is mentioned minus 10 by 7. Yeah, so then answer must be negative for lambda. Otherwise, this angle never be 90. No. Okay. Anyway, we know If this angle is 90 people, this OB vector and OC vector perpendicular. Then you can write BOC angle pi by 2 means OB vector is perpendicular to OC vector. So when two vectors are perpendicular, people, you know the dot product of the vectors should be equal to 0. Right. OB vector 2y plus OJ dot OC vector, this one, 2 plus 3 lambda I 4 plus 2 lambda J should be equal to 0. You know, when you take dot product between two vectors involving I and J in the vectors, how take I coefficients we multiply, J coefficients we multiply. That's how simplify that. Then we get 2 times 2 plus 3 lambda. And next one, 4 times 4 plus 2 lambda. 4 times 4 plus 2 lambda should be equal to 0. Here we have 4, here we have 16, then 20. Take right hand side, minus 20. Here we have 6 lambda, here we have 8 lambda, 14 lambda. Lambda going to be minus 10 by 7. This way we get value of lambda. Okay. The last question. Last question. It is Copeland forces question. A uniform rod AB is kept in equilibrium with its upper end A testing on a smooth pig. By applying a force P to its lower end B at an angle beta to the vertical, as shown in the figure. The rod makes an angle pi by 6 with the horizontal. Show that tan beta. Right. Number 8. Here A. Right. AB. Uniform rod. Weight is at the midpoint. Here this is a pig. Smooth pig. The reaction by a pig is perpendicular to the rod. R, suppose. This way. Perpendicular to the rod. I'll assume the weight as W. This is the horizontal. This angle pi by 6. And here vertical. Okay. A force applied here, P, that makes an angle beta with the vertical. This angle is given as beta. Right. I'll assume the length of the rod dash 2A. It's a uniform rod, center of gravity at the midpoint. Okay. Now asking tan beta equals root 3 by 5. Now people, we write the equations for the equilibrium of the rod. Resolve horizontally, resolve vertically, take moment. By the three equations, you can show this answer. Right. Right. No? For the equilibrium, you can write that of the rod. Resolving forces. Rightward. Here P, this is beta, no? P sine beta. W vertical, no component horizontally. By R, when you draw horizontal line here, if this is 30, this is 30, then this is 60. R cos 60 should be equal to R cos 60. R cos 60. Huh? You know cos 60 is half. Okay. Then we get P sine beta equals R by 2. R here half, I take here 2. Number 1. Resolve vertically upwards. Then what we get? P cos beta. Here we have 30 and 60, and this is 30 plus R cos 30. R cos 30 is equal to what? W. Let us take this as, yeah, we can substitute for the cos 30. Right, cos 30 root 3 over 2, no? This way, W number 2. Now we take moment around B. Take in moments around B. Take this a anti-clockwise sense, we take moment. Then, you know, this R is already perpendicular to rod. When you take moment around B, R will give around B anti-clockwise. What is that? R into 2A moment. But this W gives clockwise moment. Therefore, I write W on the right hand side. Moment of W. W into, when you produce this way, the perpendicular distance is A cos pi by 6. Right. A and A you can cancel down. R equals W cos 30 root 3 by 2, no? These 2 also come in here. We get 4. Right. Now people, this R we can substitute where here. And then you can find P. That R and P both we substitute where in number 2. Then we get the answer for tan beta. Okay? Right. Now you can write. Now by 1. Right. We can write P. 2P sine beta. 2P sine beta equals R, no? R is root 3 W by 4. Then we can subject P by this. Root 3 W. Bring this 2 here and sine beta here. 8 sine beta. Now this P value and this R value, both we substitute in number 2. In number 2. Okay? Now by 2. Now by 2. P. This answer. Root 3 W by 8 sine beta, and here we have cos beta plus root 3 by 2 r root 3 w by 4 equals w. W you can cancel down. You get 1. Okay. Then here we can take root 3 by 8 cos beta by sine beta. It is cot beta. Here we have 3 by 8. Take to right hand side, but right hand side we have 1. This way. Now take common denominator as 8. Oh, multiply both sides by 8. Root 3. We multiply this by 8, this by 8, this by 8. This 8 will cancel. Root 3. Cot beta I write as 1 over tan beta like this. 8 minus 3. It's 5 now. 8 minus 3, 5. Then use the cross multiplication. Tan beta here, 5 here. We get this root 3 by 5. Okay. Root 3 by 5. This way we can take the answer. Right?